Good evening. Good evening. Today's class is on electron beam welding. Right. So the name itself, it says that we are using an electrons in a specified path called as a beam, which will impinge on to the workpiece. So coming to this, it's an advanced technique where you can weld and high thickness materials. Right. So here you can see there is a cathode. Right. From the cathode, the electrons will emit through a gun, and these electrons gets accelerated when it strikes the anode. Right. So when this accelerated electrons, when it travels in a specified path, it comes in contact with the positioning diaphragm. So here it gets deflected, and here you can see there are two lens on the either side, which will help in focusing the beam towards the workpiece. So here there is a rectangular shape, which you call it as a keyhole. So first what will happen, this beam will start impinging a keyhole. So when it impinges a keyhole, the material at the extremes will melt. Right. So again the beam will propagate in this direction, and the melted part will fill in the holes. Right. So filling and creating a hole will continuously done in the specified direction where you want to weld. So this is electro beam welding. So the main parts is cathode, anode, positioning diaphragm, electromagnetic lens, and workpiece. Right. So here in electromagnetic beam, the main advantages is here it can penetrate into the workpiece of about 10:1 ratio. It means the depth to the width ratio is 10:1 to 30:1. Right. And here you can no need to use the filler material, and here the heat liberated is very low. Right. So there is a topic called heat affected zone, which is you can see in this diagram. Right. So when I am welding a workpiece, these are two different base metals where I want to join with a V joint. Right. So here this is the bead. Right. So this is the joint where I would like to weld. So this will be in a liquid state. The borders of this, the neighbor grains will be in the solid state. Right. So here the grains will slowly decrease the size. At this border it will be of large. So here it will start decreasing. So this area is the one which will have an alter in their properties, though it is not welded. Because of the neighbor welding zone, even this layer will have a change in properties. So whenever you do any welding process, the heat affected zone should always be less, because in this zone there will be a change in the properties. So when you take in terms of strength or hardness or any mechanical properties, this heat affected zone will change the ability of the material. So here you can see the grains are large, and slowly it is been increasing. So this is the zone where you can see a change in properties, because it is in touch with the welded bead. The area where you are joining, you call it as bead. So that will have an influence on this area. This is called heat affected zone. So in electro beam welding, this heat affected zone is very less, and very thick materials also you can weld very easily by electro beam, as you are only using the beam. Right. So you are not using any filler rod, so you cannot have an oxide layer deposition. Right. So one of the advanced technique is electro beam welding. Thank you.